All right, my name is Tyson Marlowe. I'm with ColdJet, and today we're going to talk about cleaning with dry ice, ways that you can reduce cleaning costs in an environmentally friendly way in your factory or plant. I have been with ColdJet for about 15 years. I have talked about cleaning with dry ice in many different industries around the world, but I'm excited to talk to you about applying it in the foundry industry today. First, I want to talk a little bit about what is dry ice blast cleaning. You got to think of it sort of like a sandblaster, but we use dry ice particles as the media. We take those particles and we accelerate them with compressed air to high speeds, upwards of 900 to even 1,200 feet per second. When those particles hit the surface, some unique things happen. Probably the most unique or the most obvious is on impact, the dry ice particles turn to gas. They sublimate, going directly from a solid to a gas. This brings a number of benefits, but most importantly, it disappears and there is no secondary waste. If I were to clean with sand or water or chemicals, then I would have contaminant mixed with that media that I would have to dispose of. In this case, there is no secondary waste. I only have the same amount of waste that I started with. It's just moved from one place to another where it's easier to clean up. So I want to talk a little bit about the details of how it works. Dry ice particles, it is actually a solid particle or CO2 particle, so there is some kinetic effect, some impact energy. But dry ice is a very soft media, so we have to get, I mentioned we have to get it moving pretty fast, but it has little hardness, which is a good thing because we can clean without damage. But there is some impact energy. Dry ice is also very cold. It's about minus 109 degrees Fahrenheit or minus 79 Celsius. So it creates a temperature differential between the contaminant and the substrate. Now this is just a surface effect only. It's not going to quench the mold or damage heated mold. In fact, dry ice blast cleaning works faster if the surface is hot because there's a higher delta T there. Then the third way that it cleans is there's a gas expansion effect. When those particles go from a solid to a gas or sublimate, they expand about 800 times. So it's like little explosions on the surface, and it really is pulling the contaminant off from the inside out. So there's an instantaneous three-part action going on there. There's that impact or kinetic effect. There's the thermal shock effect that shrinks and disbonds the contaminant, and then there's the gas expansion effect, which flushes off the contaminant from the substrate. Also, you have compressed air driving the particles, and so that will move the dirt or contaminant from one place to another where it's easier to clean up. Why do I want to use dry ice? Well, because it disappears, it's kind of the ultimate clean in place tool. You can clean online, in place, while things are hot, which means you don't have to spend time disassembling, and you can spend more time running, less time preparing and things like that. We can get into very tight spaces, and it's not with very small particles, and do even precision type cleaning. It's not going to leave any residues like a chemical would, and it certainly doesn't require any rinsing or anything like that. I mentioned before that dry ice is a soft media. In the next slide I'll detail that a little bit more, but it does not etch or profile most metals. This means I can clean a mold or pattern in the press while it's hot online, and I just go right back into production immediately. It is a dry process. It's non-corrosive and non-conductive. I can clean an electric motor while it's running. So I don't need to disconnect things from power. I don't need to mask sensors. I can clean around all of those sorts of things without worrying about damage or harm from moisture or anything like that. Finally, dry ice is an environmentally friendly way to clean things. Yes, CO2 is a greenhouse gas, but we are not a producer of CO2. We actually just change it from one nature to another. So the dry ice that's used in cleaning is taken, harvested from some other refining process or something like that. It's turned to liquid, and then we just turn it back to gas as we use it. So we're a net zero producer of CO2. It is non-toxic and food safe. In fact, most dry ice is used as some sort of a cold chain management process to keep food cold or transport food. So on this slide, we compare dry ice particles to other types of media grit blasting, and this is Mohs hardness scale for minerals. This compares hardness, of course, of each of these types of media. You can see that dry ice is about a 2, about the same as gypsum on this scale. It's very soft. It's probably something about the hardness of your fingernail or something like that. It's very, very soft. It does not etch, profile, scratch most metals, and we can clean even very delicate things without damage. It's quite versatile. I can turn it down to take the M off of an M&M candy, believe it or not, or take the ink off of a business card without punching through the paper, or I can turn it up to even remove weld slag or some paint coatings and things like that. So I can be quite versatile with it. But the main thing is I can clean without damage and I can clean without secondary waste. It's the only one of these medias that disappears on impact. So I would like to talk a little bit about dry ice because most people are not very familiar with it, at least in all these different forms. Most of you have probably seen it in the grocery store in block form or slab form, but the most common actually is in pellets, in different sized pellets, as small as 1 millimeter in diameter, and I've seen up to 22 millimeters in diameter, but it just depends on what the customer wants. Again, part of a cold chain management. The dry ice is made from recycled CO2, as I mentioned. The gas is harvested off of some sort of refining process. Here's a couple of pictures. One of these is an ammonia plant, one's an ethanol plant. But you'll see an industrial gas company like Airgas or Praxair or Air Liquide, Linde, they'll set up next to these producers of CO2, these refining plants. They'll harvest the gas and they'll turn it to liquid. They compress it and refrigerate it, turn it to liquid. They can store it and transport it as liquid. Then they take that liquid and they run it through a machine like what you see here in this slide here in the picture on the left. This is known as a pelletizer. It makes pelletized dry ice. Basically, they squirt the liquid CO2 into one of these chambers. You can see 4 barrels on this particular machine. This machine will make about 2,400 pounds of dry ice per hour. This is one of the larger machines around. But basically, when they spray that liquid and change the pressure to ambient pressure, about half of the CO2 will flash off as really light powdery snow. And then they have a big hydraulic press here. As you can see, that hydraulic cylinder will press a piston forward and extrude that CO2 powder. It'll turn it into a very hard solid through a set of dies here. You can see the dies in the middle, different sizes. But it extrudes it, and it kind of looks like a pasta maker. But what you end up with is 3 millimeter pellets, like you see in the bottom picture, you scaled by that pencil. It looks like rice, about the size of rice. So you take those particles and accelerate them, and they become a good cleaning media. We can also use block dry ice. In this case, we would take the blocks or slices and shave them into what you see here as sugar-sized particles. Typically, they're anywhere from 0 to 0.3 millimeters in diameter, but again, you can see scaled to the pencil there. But there are machines that can use any type of dry ice to blast clean with, and it's important in the foundry industry because there are different applications that use both types of dry ice, blocks or slabs and or pellets, depending on what you're trying to clean. And you would manipulate the size according to how aggressive you wanted to be, or that sort of thing. So there are some machines that are made just to deliver pellet cleaning. They only work with 3 millimeter pellets. Dry ice, because it's so cold, can actually be a little bit difficult to work with if you don't have a good system to handle it. It's cold, so it will draw moisture out of the air and freeze that water ice and clump up into a big ball of dry ice. But machines, they have insulation, they have agitation and sealed lids and things like this to deal with keeping that dry ice free and moving. And any good machine, well-designed machine, will be able to move that dry ice all the way through the system. In other words, you put in 3 millimeter pellets, you get 3 millimeter pellets out at high speed, or even more importantly, you put 0.3 millimeter pellets, if you're shaving a block, into the system and you get that out. And this is what a block shaving system would look like. This top machine here is a tabletop unit. It's designed to do, the nozzles are about the size of a pen or a pencil. It's designed to do precision type cleaning, or even small electronics or things like that. We can do some very delicate cleaning. Or this big machine here on the bottom right will take blocks, pellets, whatever you put into it. It's designed to work with any type of dry ice. But again, they will manage the dry ice accordingly. Even though it's very cold, they'll mix those particles with the compressed air, and you will get full particles at full speed to do the cleaning. Dry ice actually will be delivered directly to the factory or job site or wherever you need it. Again, industrial gas companies like Airgas or Praxair or Linde or Air Liquide, people like that will make dry ice and deliver it in insulated containers. This particular insulated container you see here in the picture, in either of these pictures, will hold about 500 pounds of dry ice. That's usually the minimum order. And they will deliver it with 48 hours notice. It's quite easy to get anywhere in North America. Or a lot of times when people are doing regular cleaning, they will just have a standing order and it will be delivered every week. And sort of like a milk run, they'll drop off the full ones and pick up the empty containers. Dry ice does begin to sublimate as soon as it's made, so it needs to be kept insulated and out of the regular air, so it keeps the moisture out. The shelf life is generally 7 to 10 days, but you won't get it until it's 2 to 3 days old. So once you get it, it's typically a week. But it is very easy to get. The price in North America is generally between 30 to 50 cents a pound, depending on where you are. So if, a 500 pound bin in the neighborhood of $150 delivered, and one of these bins is going to get, depending on how much you use per minute, typical is 2 to 3 pounds. So that could get you anywhere from 5 to 8 hours of blast cleaning. Of course, you're not going to be pulling the trigger every minute. So typically one of these containers will get you a full day, 6 hours to 8 hours of blast cleaning. So, and you just scoop them in the machine, and I'll show that in the next slide. But the compressed air systems are what drive the machine, much like any media blaster. We're using, for the larger machines, we're using ranges of air 50 to 175 cubic feet per minute at 80 psi. The machines will blast more than that. And then, of course, portable diesel compressors are available as well. And those can be used any size. We can blast up to 300 psi, but typical shop pressures are in the neighborhood of 80 to 100 psi, and that's fine. Really is a pretty simple setup, and it's quite user-friendly. You need a source of dry ice, compressed air, and a machine hooked to the compressed air. You do need 110 power. It will pull less than 10 amps. The electric motor on the inside of the machine meters the dry ice into the feeder, and again, it just pulls less than 10 amps, but it makes it very convenient. And then something to clean. So it's kind of a point and shoot. There are some techniques, and you will get better at it. Typically, you're 2 to 6 inches from the surface, moving back and forth rather quickly to clean the molds or any part of the plant. Even I've seen people clean even ceilings and walls. We'll get into the applications here in just a minute. Personal protective equipment. Again, because of compressed air, we need hearing protection. Sometimes people wear double hearing protection, earplugs and earmuffs, because it can be loud. I've seen or heard over 100 decibels, depending on the factory that you're in and also the surface that you're aiming the dry ice blaster at. Those sound waves can come back to the operator. However, because it's high frequency noise, it dissipates rather quickly away from the operator. But most of you, in fact, if not all of you, will have hearing protection programs in place already, so that will suffice. Safety glasses, because it is a blast cleaning operation, so we definitely would require safety glasses. And Many people will use a face shield because there's not for the dry ice necessarily, but because there's debris coming off of whatever they're cleaning, the contaminants flying off of the substrates, and so definitely could want to use a safety shield. Gloves are required to handle the dry ice. You can touch dry ice without damage, but handling it for long periods of time because it's so cold could cause some damage, so you definitely need to wear gloves. And then you see in the top left corner there's a CO2 monitor, and CO2 can concentrate because it does displace oxygen if you're in a low area or a confined space. In an open shop environment, you have enough air exchange already, and it's fine. But again, if you're in a confined space or a low area, you'll want to increase the air exchange in order to keep the CO2 from building up, where it will displace oxygen or actually could become poisonous at certain levels. And then you see in the bottom, you see somebody wearing Tyvek and a respirator. That's not necessary for the CO2, but it could be in certain environments where we do a lot of remediation, restoration type work, and so they could be blasting black mold or something like that. And so in that case, then the person would want to have that kind of protective equipment. But just for blasting in an open shop environment, hearing protection, eye protection, and gloves to handle the dry ice. Pretty simple. In fact, you're probably wearing all of those things already anyway. So I'd like to kind of get more towards the application of dry ice blast cleaning now. Industries and key customers, before we get too deep into the foundry industry, I show you some examples. Just thought I'd talk through some of the other applications. There are so many when it comes to cleaning in place, so many different industries, but any type of molding process, just as in the foundry arena, whether it's plastic or rubber molding or even food molding, there are buildups where you want to be able to clean them without damage. You want to do it with a dry clean, and you want to do it in place with as little disruption to production as possible. So think about all the applications there in aerospace, automotive. Think of how many parts on a car are molded, whether it's plastic, rubber, metal, or even welded. We can do weld line cleaning too. In fact, it's used regularly in the automotive industry on weld lines to clean weld slag, spatter, degreasing, soot buildup, and again, right on line, around the robots, even around electronics, cross-connect boxes, things like that. It's also used a lot in the food and beverage industry. You can imagine how a flour miller or a chocolate manufacturer might like to have a dry clean. They don't want to introduce water where they don't have to, and they certainly want to cut down on chemicals. Power generation is a good one for us because anytime there are heat exchangers, which is a lot of power generation, or oil and gas, or lots of heat exchangers, radiators, things like that, we can clean all of those things without damaging them. And when they're clean of the buildups that all of them get, they tend to run more efficiently, so they use less power to run, or they create more power because they're clean. A lot of fire restoration and mold remediation work, historical rehabilitation. Anytime there are adhesives or inks or grease or any type of lubricants, dry ice blasting works to clean in those areas. About 15%, maybe a little more than that, of the machines that are sold go to service contractors who provide a cleaning service. And this is true also in the foundry industry. It's probably more true for facility cleaning or equipment refurbishing rather than online production cleaning, but that is a type of service that is available. All right, so let's talk a little bit about specifically the foundry industry. One of the things that uses dry ice to clean regularly is core box cleaning. And you know, core boxes have a lot of vents, a lot of screens, things like that can get damaged easily if you're not careful. And we're able to clean those with dry ice and even clean right through the vents without damaging them, so they don't need to be replaced. Core boxes can be cleaned whether they're made out of metal or redboard, even different types of polymers. If they're made out of wood, unfortunately, we cannot clean them with dry ice. The dry ice will damage wooden core boxes. But we're able to clean these quickly. No matter the temperature, no matter where they are, we can clean them quickly and without damage. Even in tight spaces, tight corners, and the screens and vents, it'll clean right through the vents. It's a really good application, getting all of the adhesives and binders and sand particles and things like that out of there. It's a very fast and efficient clean. Refractory coatings. Now, you'll see pictures here, different types of refractory coatings. The talc-based ones are fairly easy to clean. Even calcium chloride, which you see on the bottom left, can be cleaned. The ceramic-based ones, dry ice is not aggressive enough to do, but on these others, like you see in these pictures, it does very well and very fast. Now, these molds are outside of the press, and it's only so we can get a good picture of them so you can see what's happening. But the real benefit here is to be able to clean these things online in the press while they're hot, and so you can just clean them right in place. Now, you can do, benchtop or tabletop or away from the press cleaning as well, but an added benefit is you can do it right in place. So here's some pictures of different types of molds, different types of buildups, from from carbon to lubricants to refractory coatings. But you can see even small, very precision type cleaning we can do, as you see in the top two pictures on the right. They're cleaning right in the press. It is not going to damage these metal parts at all. If I clean with a wire brush or Scotch-Brite or something like that, or chemicals, it could etch or scratch the metal on these molds or knock off corners or things like that. Dry ice is not going to change them at all. It's not going to change the appearance. They will look as new on day 500 as they did on day 1, cleaning with dry ice. Also, you can see in the bottom right picture, you can see a lot of tubes, maybe wires, other things like that. We can clean with dry ice around those areas without damage, and even clean them without removing insulation and other things like that. So we can do all sorts of different types of cleaning, from aggressive to delicate, and we can change on the fly with our nozzles. We have the capability to slow down the particles of dry ice and even change the size of the dry ice right at the operator, so they can go from aggressive to delicate on the fly. See a lot of general type cleanup in foundries, whether it's cleaning failed paint or dust on the ceilings to floors, catwalks. You can see here just from grease to oil to carbon to all sorts of buildup. Man fans, they run more efficiently, use less power, use less electricity. A lot of man fans in foundries, I've noticed, but you can use these dry ice plasters to clean even those sorts of things. It does really well on oil and grease, as you can see in the bottom left here, and you can see even the letters and things on that part, on that valve, are still there. It just looks clean, and that's very typical of dry ice cleaning. It takes off of the contaminant, but it doesn't damage the surface of what it's cleaning. So, all right, just to review some of the advantages of cleaning with dry ice. Maintaining surface dimensions is very important, which is true in any kind of molding process, of course, especially including foundries. If that's important, then dry ice could be a good tool for that, because it doesn't damage the surface. If you are currently disassembling and spending a lot of time doing that, dry ice could be a good tool for you, because you don't have to do that as much. You can clean things in place, which means you're not going to disrupt production as much. Also an advantage for dry ice. Typically, we find that labor-intensive means expensive. It means it takes a lot of time to clean, and often it means there's no good way to do it, so it doesn't get cleaned. And so then you have unexpected shutdowns. You end up having to replace parts instead of clean them and go back, because there just isn't a good way to clean them. So if it's labor-intensive, that could be a good sign that dry ice will work for you. Water or chemicals cannot be used, or you just don't want to introduce water, or you have places you don't want to use water or chemicals. That's a good place for dry ice typically. Grit entrapment, dry ice disappears on impact, so there's no problem there. So in general, if surfaces need to be free of residue or contaminants, hazardous waste is always a concern, and it's getting expensive to deal with. Dry ice can be an effective tool in those situations. Uh, just a few more things. If there are, I think I covered all the usual questions I normally get on a webinar, but my contact information is here, my email and my direct phone line, tmarlow@coaljet.com, and area code 513-716-6323 is my direct line. Our global headquarters are in the Cincinnati, Ohio area, and I'd be happy to answer any questions or help in any way possible. These machines are quite easy to get a hold of. It's easy to have someone come in and demonstrate their capability. They're easy to rent, both short and long term. They're easy to lease or purchase or anything like that. There are contractors available to do the work. But be happy to talk about that. We have a lab in several places in the United States where you can send parts to be tested as well. That might be a good option for you. We are very excited to be exhibiting at the upcoming CAST Expo in 2016. We'll be in booth 2249, and we will be doing live demonstrations in the booth.